Hello everyone, welcome back to Ampnics. OpenAI has just launched GPT-5 and they are claiming that GPT-5 is one of the most smartest, fastest and useful models so far. In this video, I'm gonna challenge it for designing a complete hardware. We will basically turn our idea into complete manufacturable PCB. So let's get started. So I already written all the prompt for designing this complete hardware, and you can also get the prompt in the description box as well. So why I did like this, cause I don't want to make the video too long. So for that reason I already written the prompt in my notepad. I will copy it from here and I will paste it here. So basically this prompt is saying create a detailed textual block diagram for 6-channel home automation device using ESP32, Room32 and Triac-based switching for household applications such as fans, LED lights, sockets, etc. The design should include the main functional blocks such as power supply, microcontroller, switching interface, error LED, programming and debugging port, safety components. Answer concisely. So let's see how GPT-5 is going to respond on this prompt. Alright, so here's the response of ChatGPT on our prompt. So let's see what's the block diagram and top level block diagram for it. So basically we have here AC mains, live and neutral. So this is just for connecting the switches. Basically between this we will connect our devices. Alright, then we have input and surge protection things like MOV, gas discharge tube, common mode choke. Okay, and at this point if you're not getting something, do not worry about it because I will explain it in the schematic diagram again. So we will just go through once only. So we have main switches, isolation RCD. Okay, we have power supply, isolated AC to DC. Why we need it? Because our ESP32 need that supply for powering up the low powered devices. So for that we need a AC to DC converter, and along with that we also need a LDO or a synchronous converter. Okay, this is actually a good suggestion. Then we have our ESP32, which is basically responsible for the communication, and it will also act as a brain for operating and for managing all the device, switching it on and off. Okay, for we have designed few projects using AI tools such as DeepSeek, Grok AI, ChatGPT, Google Gemini. So there was something different in every project. If you haven't seen it, make sure to watch these videos. You will get to learn something new. But ChatGPT 5 is quite different than before, and we are getting the better response from it. Okay, then we have a programming and debugging port. So it is also suggesting us the devices as well, such as CP2102, CS340, and it is also telling us about what is the purpose of these devices. This is basically for flashing the firmware or serial debugging. Okay, so this is quite good. Then zero cross detection, this is basically for Triac. So we'll talk about it. Switching interface. So this is going to our main block for switching the devices, which we will use in the circuit. Okay, then current sense and over current protection. And if you notice one thing, that it is including everything. Like not everything is required, but if you just want to make a commercial product, then you should take care of all those things. But being a hardware design engineer, you don't have to only worry about technology, also you have to take care of the budget of that project as well. So then we have status and error indicator LEDs, and we have some reset and boots buttons. Okay, input, user input locals. So we can add some push button for toggling the things. Then communication with external IO Wi-Fi. Yes, we are going to use Wi-Fi only. We don't want to use UART or I2C as of now. Okay, so the signal flow summary is like mainly we will have our Live and neutral, we will have our power supply, which can be isolated or non-isolated. But if you want to make a safer system, then you can go for isolated power supplies. That is much better than non-isolated one. But obviously, it is more expensive than uh, isolation, a non-isolation one. Okay, then we have live and track in between load. So basically this is a kind of very informative. We have to add the live wire, then in between triac, then we have our load. So I will explain you in schematic as well, that how you can basically understand it. Okay, so uh, for turning on this triac, we need optocoupler as well. So basically there will be some isolation for turning on the triac directly with the microcontroller. Okay, then further we have this is something that we are not going to do in this PCB. And fault from current or voltage, these are the features that we are not going to use as of now, because this all these things are more than sufficient. Now I will ask for the device selection for it, and let's see what are the devices it will suggest us to select for designing this schematic, so that we can follow this block diagram for designing the schematic in KiCad. Suggest the most suitable component for each block. 6-channel ESP based Triacom automation, include part number and voltage current rating, package types, justification for each choice. Keeping cost, availability, reliability in mind, consider optocouplers, triac, power supply modules, protection devices, and connectors. Answer concisely. Alright, so here's the response of ChatGPT 5 on the device selection. We will check it. Core module. So we have ESP32, Room 32. So basically, this is the main brain of our whole project. Why ESP32? Because it supports Wi-Fi DLE and widely available FCC and CE certified. So which is good for productization. Okay. Then we have power supply. So for AC to DC converter, we can use IRM -10 -5. So we can use this one, and this is basically 5 volt to ampere supply. But although it is isolated one, then it is going to be expensive also. So we will use a different supply instead of using this one, so that we can save our pricing on bill of material. Okay. Although if you are concerned about more efficient supply or more safer supply, you can go with this one. Then we have 3.3 volt regulator. So for 3.3 volt, we got couple of choices, that we can use MIC 5219 or TLB 111733, or we can use AMS 1117. So we will choose AMS 1117 2.3. So we will choose this one. Okay. Then main search and input protection. So we have to use the MOV, and we can use this one. Okay. 14D471K. So this is 470 volt varistor, and 300 volt AC rating with 14 radial size. Okay, so this is pretty good for such application, and we can use this one. And apart from this, we have to use fuse also, and the fuse is one of the most important device in such application. If there is uh, high current consumption, or like something happens unexpected, so this fuse is going to always save your device. So it is good approach to use fuse in your project, and GPT-5 is exactly suggesting us to use it. It is really good. And again, it is suggesting us to use TVS diode on the output side. Well, I will let you know one thing, that not every time it is mandatory to use TVS diode at the output side, because there's something that you will observe in the physical world, that there is a difference between theory and practical things. So sometimes it is easy and it is considerable to not concern about everything. Okay, so we are going to skip this part. Again, zero cross detection. So we are going to again ignore this point, zero cross detection as of now. And if you are really interested about it, you want to study about it, I will paste some link in the description. You can go and check out about it. Okay, then we have Triac drive. So this is the main switching side which is responsible for switching the loads, and it will take the signal from the microcontroller and it will switch the AC devices. So it cannot take the signal directly with the microcontroller. What it will use, it will use optocouplers in between, and the optocouplers are like MOC 3021, okay, and MOC 3063 when you use zero cross. We are not going to use zero cross detection, so for that reason we will use MOC 3021. And for Triac we have to use BTA 16600V. So this is also a good suggestion, so we will stick up with this one. All right, also it is suggesting us to use the gate resistor somewhat between 100 to 330 ohm. Okay, and this is pretty much good to go. Okay, then current sensing, again we are going to put this part here, and protection and suppression, again we are keeping this. For the load also it is use protection circuit. Okay, then for programming and USB port, so we can use CP2102N or CS340G. So these both suggestions are quite good, so we will choose 340C or 340C because CP2102 is quite expensive and we don't need to program it again and again. So CS340 seems perfect for our application. Okay, then for connectors and mechanical stuffs, so it is suggesting us to use Phoenix DFK MSTB 2.5/5.8. So basically, it's a terminal block type of connector that we can utilize it for connecting the external load. Okay, so this all device selection is pretty much good, and if you have little bit basic understanding of electronics, then you can definitely use the AI tools for designing the better hardware. I already designed the schematic in KiCad, and if you are someone who don't know how to design the schematic or layout in KiCad, you can check this playlist how to KiCad. Basically, in this playlist, I have explained everything that you need to become expert in KiCad. So this playlist is having like short videos for explaining every topics that you need in the beginning. So here we have differentiated the things on the basis of their features and significance. So I will explain you one by one. So first we have power supply. So this is HLK5M05. So this is basically responsible for converting AC voltage into DC voltage, and the output of this supply is about 5 volt, which is responsible for providing energy into the switching side and the microcontroller. Alright, along with this is the input of this converter. Here we have some protection devices such as a fuse, MOV, and some capacitor and PC. So these are the few required devices for protecting our converter. Then further we have a LDO. Why we need LDO? Because microcontroller works on 3.3 volt and we are getting 5 volt output from this converter. So for that reason we are using a LDO also. Alright, so this is our basically a power supply section. Then we have a power pin. So this is for external use. If suppose you want to add something in future, and if you want to get this voltage for connecting to any sensor or something else, then at that time you can utilize these pins. Then we have error LED. This could be used for status, or if something happens or something fails in the PCB, then you can utilize this LED as a debugging thing. All right, then we have the main switching circuit, and in this switching circuit we have a optocoupler which is taking the input from the microcontroller, all right, which is taking the input from the microcontroller and passing that data into the triac. So basically this is a kind of isolation thing, and it is basically uh, communicating, or can say it is basically switching the triac on the basis of signal of the microcontroller. So just like this circuit we have copied 6, so that we can automate up to 6 channels or 6 devices. All right, so this is for 6 devices. All right, if you notice in this circuit that we have a LED symbol and have a diode here. So when this positive pin, which is controlled current controlled by a resistor, when the current enters, so this LED glows and then diode activates. By that our triac comes into action. This is very simple circuit for switching the AC load. And further, we have a connector for switches, so that we can use manual switches like rocker switch or push button. For that reason we have added a pull-up resistor as well. All right, then we have connector for loads. This is our main brain of this project, which is this ESP32. And ESP32 is have some decoupling capacitors and reset and boot button. All right, then here we have programming and debugging code. So if you are planning to make it as a product, do not make this programming code or debugger. Instead of using this, you can use test point for uploading the program. And if you are someone who is looking for developing commercial product or any project, you can always reach out to us for doing the project. The contact details are in the description box, and you can download this schematic and all the related file of this project from GitHub repository. The link is in the description. Okay, so what we will do now, we will review this schematic, export this schematic, and I will ask it to ChatGPT, is there any error or not? And let's see what are the problems or what are the things is all right in this existing schematic. So now I will upload the PDF of that schematic. So I will click here plus and add photos and files. So just attach the schematic file here, and I have written the prompt again. So I will copy this. Okay, I will paste it. So the prompt is very simple, that I have designed a schematic for 6-channel ESP32 ROM32 Triac-based home automation board. Review this schematic for functional correctness, safety, manufacturability, and suggest any improvement in the circuit design, component values, and safety isolation. Then give PCB track design suggestions such as track width for mains voltage, pre-page clearance requirements, grounding strategy, and EMI reduction techniques. Did few modification on the basis of budget and requirements. Answer concise. So again, the things that we want and which we discussed earlier, did we ask the same thing? That's the response of ChatGPT. Took 15 seconds for reviewing the complete schematic, and let's say what are the key findings. Okay, so the power you use, we used HLK 5M05 and AMS 117 to feed ESP32. Good isolation, but AMS will dissipate heat inefficient. Triac path MOSI is 3021. Optotrax feeding DP136 500 triacs per channel, and small component value gate resistors number present. Good topology for phase control, right? And USB to UART 3 CS340C present. Schematic shows the bus DD lines. Check correct 3.3 volt variant and auto boot wiring. Okay, indicator and switches present, wiring looks okay. So basically These are the things that are already fine. We don't have to worry about anything. Okay, so our schematic is fine as per ChatGPT saying that it's all right. Okay, so what are the key recommendations that ChatGPT is giving us that what we can do? So replace the BT 136 500 with 600 volt part with more margin. Example BTA 16600 or BTA 24600 for socket heavy channels. Means spike or inductive loads may need uh, sub RRM surge headroom. Okay, so basically here, so replace BT 136 500 with a 600 part like BTS 16 600 or BTA 24 600. So this is basically for when we attach the inductive loads it spikes, so it's better to we can replace. So as I discussed earlier that this PCB is for automating the general purpose load and we are not attaching very heavy load into it. So as per our requirement, BTA 136 is quite good. Okay, so for opto driver current and drive topology, so MOC 3021 needs higher LED current reliable triggering at high mains voltage through series resistor directly from PSP 32 3.3 volt wire. Single series resistor 270 gives 7 to 8 milliamps. Aim for 12 or 20. So basically, ChatGPT is suggesting us to use a less value resistor. Okay, so we will decrease the value of resistor and what is the recommended value? We can use 150 or to 220. So I will replace all these value and I'll make it 150 ohm. Copy this. I will paste it. All right, so we have updated the value. This snubber and protection. So use an RC snubber across the Triac load. So basically, this is for external layer of safety, but I already used this configuration before in a commercial product and it works quite fine. So uh, as of now, I will ignore this again. Okay. So fusion fault isolation schematic shows that F1 is about 1 ampere. Ensure fuse rating is chosen for worst case and total load if board which switches multiple loads concurrently use per either channel fuse or singly appropriately rated for slow blow main size or total expected load margin. Consider adding a thermal cutoff or polyfuse on output if cost permits. So it is suggesting us to use a calculated value exactly like how much maximum current you can consume if the board is fully functioning. So if your budget is allowing you, then you can go for polyfuse. But here we are not going to use that. What we can do, like instead, when I will show you the 3D model of the PCB, then at that time I will explain you in more detail. Okay, so as of now, basically there is a suggestion that if we can, if budget is allowing us, then we can go for other fuses also. Okay, then power supply change instead of using AMS 1117, go for buck converter or like any other LDO. Basically just that. Okay, so this is something which is zero cross and sensing robustness. If you plan to dimming or like MOC 3021 on zero cross detection is okay. If only on off, consider the MOC 3063 cross zero cross opt to reduce AMI, ensure cross detection if present, has proper isolation and filtering. So again, I mentioned and I discussed earlier that we are not going to use it. Then current sensing, we skipped this part. USB to UART programming, CS340 wiring, use 3.3 version to level shift the RX and TX or TX and RX, include RTS, DTR, RTS, use DTR, RTS auto boot line connected to in and IO0 for small RCs and auto programming. Consider using CP2102 if driver support and robustness is priority. So basically here the ChatGPT is telling us that use these pins which we already used there, and if you if you don't want to stuck in driver and those kind of stuff, you can go for CP2102, but again CP2102 is expensive. For that reason we are using. Okay, then again silk screen and test point, so we can add some test point and screens for testing. Okay, so what are the PCB track insulation rules? So creepage and clearance. So keep keep creepage surface distance means like 3.3 volt and 0 volt exposed for user connectors and up greater than or equal to 8 mm for primary and secondary isolation. Recommended for many consumer IT products at pollution 2 if use basic isolation only 4 to 5 mm. It is minimum on depending on the material group or pollution degree. 8 mm is safe target. Okay. So basically we have to place the DC component uh, about 8 mm from the AC component. Okay. So basically we have to maintain this. Okay. Then clearance and air distance for them are equal to 4 mm. Okay, for tracks, three if the load is about 3 ampere, then we can go for 1 mm, or if it is 6, we can go for 1.8 to 2.5, or if it's 10 ampere, then we have mm. Okay, then for three-phase its layout, use isolation slot or routed slots underneath the main track to use the path. All right. Then for grounding strategy, protective earth point connect the earth terminal directly to the chassis in the single point on the mains input. Do not tie earth to the logic ground except single star point. Is example piece. Okay. Then EMI and noise reduction. Again, number circuit is there and IOB. Uh, then MOB is there. So these are the things like we can make our system more efficient, and since we already have those kind of things available on the board, so it is anyways it is quite safe. Okay, then manufacturability and test suggestion: add solder mask opening and extra copper around triac, thermal pad and heat, provide pad to uh, this is basically a package. Okay, 220, add sufficient test point for V in 3.3 ground RXT, TXRX for channel waveform. Okay, use standard terminal block for keeping the component spacing for assembly. Use silk screen level for mains wiring and orientation. All right, so this is pretty much good suggestion, and if you see like the response of ChatGPT 5 is way better than other AI tools, and so this is how we design the layout of our PCB, and it's very simple. For the DC signals, we have utilized 0.3 mm of track, and for AC signal, basically on the load side, we have utilized 2 mm signal and 3 mm signal. So this is basically high side. This is all the high AC voltage, and this is all our DC voltage. And the thing that you have to consider here in the programming code, that you have to make sure that data plus and data minus lines should be equal, and you have to maintain the impedance also. Don't know how to design the layout for USB track? Comment it below. I will make sure to make a tutorial on it as well. Okay, so the creepage is also quite good for as per our requirement that we kept some gap between AC and DC track. So this is pretty much good layout, and this is how I designed, and basically this is double layer PCB, so you will find few tracks on the back layer as well. Okay, so if you don't know how to design the layout, again you have to check the how to KiCad playlist where I explain everything in detail. Okay, so if I turn on the 3D view, we can visualize it better way. So you can see here, this is all the safety devices or component which required for keeping our power supply safe. Then further, we have this is our programming port, this is our antenna area. For that reason, we didn't kept anything here. And this is for connecting the switches by GST connector. Alright, and this is our actual port from where we connect our AC load. This is the switching side. These all optocouplers are providing basically isolation to AC and DC signal. Okay, so this is how we design this PCB, and you can comment it below, and you can also rate it on a scale of 1 to 10. Okay, so what I will do now, I will take a screenshot of this PCB, and I will ask it to ChatGPT rate it on a scale of 10, and let's see how much uh, number we get on this design. Okay, so I will take a screenshot of this PCB. All right, I will paste my image here, Control plus V, and I will copy paste my final PCB design. So rate my final PCB design for 6 channel ESP32 Triac-based home automation on a scale of 1 to 10. Consider electrical safety, signal integrity, manufacturability, thermal management, aesthetic layout. Provide brief explanation of your rating and suggestion. Top 3 improvement or make it even better. Concise. Everything is already perfect. But let's see ChatGPT. I would rate this design 10 out of 8. Okay, so this is pretty much a good number. Why 8? Instant clean symmetrical layout, high voltage part used in the Triacs group logically good, silk screen warning, connector orientation, looks service friendly, solid manufacturable. Positives: high voltage runs between MOV fuse PSU consistent, tri-channel spacing, neat component alignment, component microcontroller and USB positioned well for access. Okay, and gaps clearing keepage around some high voltage and low voltage trans could be larger. Triac thermally release seems minimal. EMI can be improved. Ground segregation isn't clearly visible from this view. Okay, so basically these are the few things that ChatGPT is suggesting us to improve, and uh, this is like this is something that you can consider and you cannot. So it is up to you, because the creepage and most of the important things we already considered in the placement. So let's see the improvements. What are the improvements? Increase the creepage and clearance. So maybe this is black color, for that reason that we cannot see the creepage and the layout of tracks. Enhance Triac thermally managed, add larger copper posts or had or heat sink pads, especially if you are driving 3 ampere loads continuously. So we already know that like the small bulbs or fans, they don't consume even 1 ampere of current. So uh, when the extra copper or heat sink is required, if you are consistently carrying 3 ampere of current. So since I just want to make this PCB small, so for that reason I'm making the or keeping the things very tight. Otherwise, if you want to make it very large PCB, then you have that flexibility to make it big. Okay? Then add EMI filtering, a common mode choke. Okay, so this is something that you can use, and I would also suggest you, if you are not tight on budget, then consider using a common mode choke. It will save your device. So I guess this is pretty much good number, and you can also comment it below, like how would you rate this design. And so far we have reviewed and used ChatGPT 5 for designing the complete hardware. And as you can see, like ChatGPT 5 is much better than before for co-piloting a complete hardware in CAD. Was the video on KiCad plus ChatGPT 5. I hope you found it helpful, and make sure to like this video and subscribe the channel for more techniques.